Hello, good morning students. This is your Jagadish Kumar Bandar. Today I am going to discuss the most important concept in laws of motion, that is connected bodies. In connected bodies also, I am going to focus on especially one case, how to calculate acceleration of the system. So, I'm going to give the trick how to remember the formula to calculate acceleration of the system in different situations to solve the problem in less than 15 seconds to save the time in NEET and IITs. In NEET and IIT exam, it is very useful to you to save the time to solve the problem in less than 15 seconds. Maximum it will take 15 seconds. So how to remember the formula? That's tricks I am going to give today. This is a wonderful trick, my dear student. Just observe carefully. Here I am going to consider strings all are inextensible strings. So that is our condition. First condition, strings are inextensible. Second condition I am going to consider. Pulley. It is a light and frictionless pulley. So in this section, whenever I am going to use the string is inextensible only. Whenever I am going to use the word pulley, means that pulley is light and frictionless pulley only. Here light means that is the massless pulley. Massless pulley. That means we are not going to consider pulley mass to solve the problem. That is, remember. And frictionless. There is no friction between the strings and pulleys. That is also we need to understand. So frictionless pulley and massless pulley we are going to consider. These are the considerations we need to remember to solve the problems. Support. This is the one of the chapter in laws of motion. One of the concept in laws of motion chapter. Laws of motion chapter. This is the one of the most important concept. So first one, I am going to consider one pulley, that is the light and frictionless pulley, and I am going to consider two masses. One is M1, another one M2. Another one is M2. This is one of the situation. Here I am going to consider this is the pulley. Of course. This is the string. This is the masses. If I am going to consider M2 is greater than M1, in this situation M2 moving downward and M1 moving upward. But both will move with the same acceleration. Why? Because both are connected with a string. Not possible to move one mass is more acceleration when compared to the other mass. Remember, both masses will move with the same acceleration. Here I am going to consider two masses. Both masses are connected with a inextensible string which passes over a light and frictionless pulley here. Light and frictionless pulley. That is massless and frictionless pulley. Here one more consideration, I am going to consider M2 is greater than M1. So both will move the same acceleration. Why? Because both are connected with the same string. Definitely both will have the same acceleration. But their acceleration directions are different. One body move with the downward acceleration, one body move with the upward acceleration. What is the weight acting on M2? M2G. That is the weight acting always vertically downwards on any object. Here M2G is weight acting on the body. Here what is the weight acting on the first body? M1G. If suppose I am going to consider a body is moving with acceleration A and two forces are acting. One is 2 newtons, another one is 5 newtons. Body mass is 3 kgs. Then what is the acceleration means? How to calculate? Acceleration is equal to, from the Newton's second law, net force by its total mass we are going to write. What is the net force? 5 minus 2. Why? Because both are in opposite direction. What is the meaning of opposite direction? One force is acting in the direction of acceleration, another force is acting opposite to the direction of acceleration. At the time, in the direction of acceleration, I am going to consider positive force. Opposite the direction of the acceleration, I am going to consider negative force. At the time, what is the net force means? I am going to write 5 minus 2, that is the net force, and mass I am going to write 3, and we are going to get 3 by 3, 1 meter per second square. This is the way of calculation of acceleration. Already we know that. In the same situation, here consider this is the force acting on the system in the direction of acceleration. This is the force acting on the system. Why? Because M1G, M2G are weight. Weight is also force only. One kind of force. Weight is also force only. So, weight is also force only. So that here weight force. Here force is acting in the direction of acceleration. System acceleration consider. Here on the system, one weight is acting in the direction of acceleration. One weight is acting opposite to the acceleration of the system. At the time, how to calculate the acceleration? Net force by total mass of the system. Net force by total mass of the system. Net force. Here force is weight. So that's why net weight by total mass of the system. Total mass of the system. This is the trick we need to remember. Now what is the acceleration? What is the net weight here? Net weight. One weight is in the direction of acceleration. One weight is opposite to the acceleration of the system. One weight is in the direction of acceleration of the system. Another weight is opposite to the acceleration of the system. Why? Because your acceleration of the system upward, your weight downward. Here acceleration of the system downward, weight is also downward. So this weight is in the direction of acceleration. This weight is opposite to the direction of acceleration of the system. Now what is the net weight? Net weight. Which weight is more here? We know that M2 is greater than M1 and G is constant for both the bodies. Here and here G is constant, acceleration due to gravity. That's why M2 is greater than M1 means obviously M2G is greater than M1G. That's why this in the direction of acceleration M2G is present. That's why M2 is greater. That's why net weight is what? M2G minus M1G by what is the total mass? M1 plus M2. M1 plus M2. That is only we are going to write the acceleration is equal to take the G common from the numerator. Take the G common from the numerator from the both terms. Then what happened? G of in the first term M2 remains and the second term M1 remains by M1 plus M2. That's why this is the acceleration formula to calculate such a kind of system. This is our first system I am going to consider. That's why remember to calculate acceleration, the simplest trick is G into M2 minus M1 by M1 plus M2. That's all. That's all. Second system I am going to consider. Let us see. So, before going to consider second system, again I am going to repeat the first system in simple way. This is the pulley, this is the pulley, and this is the what? M1, and this is what? And this is what? M2. So both are moving with the same acceleration, but this is moving downward acceleration, this is moving upward acceleration. Here weight is M2G, here weight M1G. Then what is the acceleration? Net weight. This weight is in the direction of acceleration, this weight is opposite to the acceleration of direction. That's why this is the positive, this is the negative. That's why M2G minus, I need to subtract from this force this M2G minus M1G by M1 plus M2. That's all. This is the simple formula. And if you want, take the G common from the numerator from the both terms. M2 minus M1 of G by M1 plus M2. That's a simple formula. It will take less than 15 seconds only to solve the problem by using these tricks. And next one, second system, if I am going to consider. Suppose this is the pulley. In this session, all the pulleys are light and frictionless pulleys. All the strings are inextensible strings only. So I am going to consider a string. Here one mass I am going to consider M1, and here I am going to consider two masses. One is M2 and another mass I am going to consider M3. M1, M2, M3. Now what is the acceleration of the system? So here what happened? All the bodies definitely will move with the same acceleration only. Why? Because all are connected bodies. All are connected bodies. So all the bodies are move with the same acceleration. So what is the weight of M2 here? M2G. What is the weight of M3? downward, all the bodies will have the weight vertically downward only. So weight force is acting always vertically downward only on any body. So here M3 means M3G and here M1 means M1G. Now this weight acting in the direction of acceleration on the system. This weight is acting in the direction of acceleration on the system. This weight is also acting, this weight acting opposite to the acceleration of the system. That's why these two are positive, this is the negative. Then how to calculate the acceleration? So these two weights are acting in the direction of acceleration. That's why M2G plus M3G. But this weight is acting opposite to the acceleration of the system. That's why subtraction, minus M1G. This is the net weight by total mass of the system, M1, M2, M3. That's why M1 plus M2 plus M3. That's all. This is the acceleration of the system. If you want, take the G as a common. If you want, take the G as a common, and you are going to get acceleration. This is the second system. Now I am going to discuss the third system. Suppose I am going to consider the third system. Consider a body is placed on the horizontal surface of the table, and here I am going to consider a pulley. So the string is passed over the pulley here, and this is the mass M1 and this is the mass M2. Now the body is moving like this. Both are connected with a string. That's why both will have the same acceleration. Now how to calculate acceleration of the system here? So acceleration of the system. And remember, acceleration of the system, suppose you will ask what is the acceleration of mass M1. Sometimes you will ask what is the mass acceleration of M2. Otherwise, what is the mass acceleration of the total system? Anything is same only. Why? Because M2 moving with A acceleration only, M1 moving with the same acceleration A only, and the total system is moving with the acceleration A only. Anything, formula is same for all cases. So previous two cases and the remaining cases, still what is there? For all the cases, the meaning is same. First body, second body, and the system, all accelerations are same only. This is the way to calculate. So how to calculate the acceleration in this system? Remember, this is M1, this is M2. What is the weight acting? M2G. Here what is the weight acting? M1G. And observe, this M1G balanced with the normal force. This is moving with the acceleration A, of course. And here M1G is balanced with its normal force. That's why, observe here, this M1G equivalent to N. That's why N and M1G both are equal and both are opposite. Two forces are equal and opposite. So that's why this weight, the net weight here, we are not going to consider. That is considered as a 0. That is considered as a 0. So that is the trick here. That's all. We are going to using the trick. What is the trick we are going to using? We are going to consider these two forces are equal and opposite and get cancelled out. And that is the trick we are going to using here. Then what is the weight acting here? What is the total weight acting, net weight acting on the system now? Only one. What is that? M2G in the direction of acceleration. M2G in the direction of acceleration. We are not going to consider M1G. Why? Because it is balanced by normal force. That is the trick we are going to using here. Now A is equal to M2G. That is in the direction of acceleration. That is only net weight here. So by what is the total mass? I need to write the total mass in the system, not only M2. Remember, total mass, whatever may be, we are going to consider the total mass in the system. I need to write in the denominator. Always remember that point. M1 and M2. That is M1 plus M2. That's all. This is the acceleration of the system calculation, such a kind of system. The third one is completed. Now fourth one. If I am going to consider one inclined plane like this, let us see here. So this is the inclined plane. And I am going to consider a block here. This is the pulley. String passes over the pulley. This is M1 and this is M2. And I am going to consider acceleration of the system in this manner. Now what is the acceleration of the system I need to calculate? So mention the weight. this is mg. This is m2, no? m2g. What is the weight on the inclined plane? Not m1g, m1g sin theta. m1g sin theta. So what is the weight on the inclined plane? m1g sin theta. Why? Because if I am going to consider any inclined plane, weight is always acting, what I said, vertically downwards, like this. Suppose this is the vertically downwards. So this weight vector, I am going to resolve it into two components. One is parallel to the plane, another one is perpendicular to the plane. So suppose inclined plane angle is theta. Suppose inclined plane angle is theta, I am going to consider. Suppose inclined plane angle is theta. Then this angle is theta. At the time, this is the adjacent component of mg. That's why mg cos theta. And this is the horizontal component of mg. So it is, this is the component parallel to the plane. This is the component perpendicular to the plane. It is mg cos theta. This is mg sin theta. mg sin theta. That's why always weight along the inclined plane acting is mg sin theta format. So what is the weight acting along the inclined plane? Not m1g, that is mg sin theta. mg sin theta. Only parallel component of original weight only will act along the inclined plane. I am going to repeat once again. Parallel component to the inclined plane. Parallel component to the inclined plane. Only acting weight on the body, weight acting on the body because of mg. So I am going to repeat here. Weight acting always vertically down. But what is the weight along the inclined plane? I need to take only parallel component of weight. Parallel component of weight. Parallel component means that the component is parallel to the inclined plane. That is the meaning. And one more component is perpendicular component to the plane, inclined plane. So I need to consider not mg along the inclined plane. Along the inclined plane, I need to consider which component is parallel to inclined plane. That component only I need to consider. That component is mg sin theta. That only weight acting on the body along the inclined plane. That's why here what is the weight acting on the inclined plane of mass m1? m1g sin theta. Here what is theta? Angle of inclination. Angle of inclination. Angle of inclination. Right. Now acceleration. So this weight is in the direction of acceleration. This weight is opposite to the acceleration of the system. This weight is in the direction of acceleration of the system. This weight is opposite to the acceleration of the system. That's why this is the positive weight. This is the negative weight. Weight is a force only. Then how to write the net weight in the direction of acceleration positive. From that weight, I need to subtract this weight. Why? Because this weight is acting opposite to the acceleration. That's why m2g minus m1g sin theta, m1g sin theta by total mass of the system. Total mass of the system m1 plus m2. Then this is the acceleration of this system. If you want to take the g common, no problem. Then what happened? From the first term, if I took g as a common, m2 remains. In the second term, m1 sin theta remains. I took the g as a common from the both terms on the numerator upon m1 plus m2. So this is the acceleration of the system. This is the acceleration of the system. Now I am going to discuss the fifth one. Suppose double inclined plane I am going to consider. I am going to consider double inclined plane. Suppose this is the theta 1, this is the theta 2. Those angle of inclinations may be equal or may not equal. In general case, I am going to consider theta 1 and theta 2. Equal or may not equal, we are going to do in the same manner only. So I am going to consider two masses connected with a inextensible strings which are passes over a light, means massless and frictionless pulley, of course. This mass is m1 and this mass is m2. Suppose it is moving in this pattern. Now the acceleration of what is the weight acting m2 along the inclined plane? m2g sin theta. What is the weight acting on m1 along the inclined plane? m1g sin theta. But here theta is theta 1, here theta is theta 2, here inclination theta 2, same inclination right down. Here theta 1. Why? Because here inclination is theta 1, theta 1, this one theta 1. Why? Because the angle of inclination is theta 1. In this system, this weight is in the direction of acceleration. This weight is opposite to the acceleration of the system. That's why acceleration is in the direction of acceleration. From this weight to this weight I need to subtract. Why? Because this is the weight acting opposite to the acceleration of the system. That's why what is the acceleration? m2g sin theta 2 minus m1g sin theta 1. m1g sin theta 1 upon total mass of the system. Total mass of the system m1 plus m2. I am going to write total mass of the system m1 and m2. Why? Because pulley has no mass. It is a massless. Light pulley, I used the word. Light pulley means it is a massless. So pulley has no mass. Strings also inextensible strings and massless strings only. Remember, strings also inextensible strings and massless strings only. So strings also massless. Light pulley, light strings. Whenever we are going to use the word light, that is massless only. Remember, massless strings. That's why we are not going to consider the masses of the strings, the masses of the pulley. Then what is the total mass of the system? Only m1 and m2. That's why m1 plus m2. If you want, take the g common from the both terms. That's all. So then what will happen? m2g sin theta 2 minus m1. I'm going to taking the g as a common from the both terms on numerator. So m2 sin theta 2 minus m1 sin theta 1 of g. Why? Because I took g from the both terms on the numerator upon m1 plus m2. That's all. This is the acceleration of this system. Now I am going to consider another system. My dear student, pause the video and note down. Okay, I am going to consider another one. Suppose I am going to consider another situation like this. Here, this is the situation. This is the situation. Here, what happened? This is pulley 1, this is the pulley 2. So, this is the m1 and this is the m2. So, here what happened? It is moving down with acceleration and it is also moving with acceleration. It is also moving with acceleration. So this is moving with acceleration here. This is also moving with acceleration here. Both will have the same acceleration. Why? Because both are connected with a string. Both are connected with a string means both will move with the same acceleration. Why? Because both are connected with a string. So both are moving with a string. Both will move with the same acceleration a, and that acceleration we need to calculate. What is the weight acting here? m1 g sin theta. Suppose here theta is the angle of inclination. That theta only we need to write here. Here theta is the angle of inclination. That theta only we need to write here. m1g sin theta. Here what is the weight? m2g. But this weight is balanced by the normal force. This weight is balanced by normal force. That's why both are equal and opposite get cancelled. This weight not involved while the calculation of net weight. This is the trick we need to remember. This is the trick we need to remember. This weight is balanced by normal force. Both are equal and opposite get cancel each other. The trick we need to remember. Remember, this is the trick. Then what is the acceleration of the system? What is the net weight acting on the system? Only one weight m1g sin theta, that is also in the direction of acceleration. So this weight we are going to neutralized with normal force m2g and normal force. That is I am going to set trick, only trick, remember. That is the trick I am going to using. m2g is balanced by normal force. Normal force. At the time, simple logic, leave it this trick, leave this mass. That is weight. Leave this weight. Why? Because my trick is m2g is balanced by normal force. Both are equal and opposite, get cancel each other, leave it. That is the weight. By using the trick, what is the total net force acting on the system? Only m1g sin theta. We know that m1 is the mass of the body, g is the acceleration due to gravity, theta is the angle of inclination. By total mass of the system, I need to write. Total mass of the system. What are the total mass of the system? Strings, no mass. Pulleys, no mass. That's why what is the total mass of the system? One is m1, another one is m2. That's why I need to write only m1 plus m2. That's all. By using this formula, we can solve. Remember, my dear student, if you are going to remember this trick, simple trick, this is very easy to remember the formula to solve the problems in NEET and IIT. And you are going to save the time. Why? Because by using this trick, you can solve the problem in less than 15 seconds, no doubt at all. That's why remember. The next one. Next one. Suppose I am going to consider the system in this manner. M1 and M2. Suppose this is the situation. This is the capital M I am going to consider. This is the situation I am going to consider. This is the situation I am going to consider. So here what happened? What is the weight acting on M2G? What is the weight acting on M2 mass? M2G. What is the weight acting on the M1 mass? M1G. Weight is always downward. What is the weight acting on Mg? I am going to write here acceleration A. Why? Because I need to write the normal force. And already you know that. On the horizontal floor means normal force will enter. And what is our trick? I am going to consider this weight is balanced by normal force. Both are equal and opposite. Get cancel each other. That is my trick. We are always using the trick on the horizontal floors in all the systems. I am going to using one trick on the horizontal floors. On the horizontal floor. On the horizontal floor, I am going to using this trick at all places. What is that? Mg and normal force. Both are equal and opposite. Get cancel each other. That is my trick. I am going to using at all cases when the body is on the horizontal floor. So use this trick. Then this weight I am not going to consider now. Now to calculate acceleration, net weight I need to consider. So totally three weights will act. One is M2G, M1G and Mg. This is I am not going to consider. What is my trick? Mg is balanced by normal force. So both are get cancel each other, equal and opposite. Just leave it. That is my trick. Remember this trick. If you are going to remember this trick, you are going to save the time. So Mg and normal force balanced and cancel out. Don't consider this weight. So that is the trick. So here what happened? M2G. M2G is in the direction of acceleration. M1G weight acting on the system opposite to the acceleration of the system. This is in the direction of acceleration. This weight is opposite to the acceleration of the system. Then what is the net weight? So in the weight in the direction of acceleration minus the weight in the opposite direction of acceleration. That is the net weight. That is M2G minus M1G upon total mass I need to write. Remember, not only these two masses. What is the total mass of the system? String has no mass, pulleys has no mass. Then what is the total mass of the system? One is M1, M2 and capital M. That is the total mass of the system I need to write in the denominator. That is the same in all the cases. That is the same in all the cases. What is the total mass here? M1, M2 and M. That is M1 plus M2 plus M. So by using this formula, one can calculate acceleration of the system. So that is only not only acceleration of the system, first body acceleration, M1 acceleration or M2 acceleration or capital M acceleration or system acceleration, anything, this is the formula. Why? Because acceleration of the system is same, A. That's why. So if you want to take the G common, then what happened? m2 minus m1 of g upon m1 plus m2 plus capital M. This is the formula to calculate acceleration of the system. Utilize students, and this is the way how to remember the tricks. If anyone want derivations for this in later classes, I am going to do the videos based on derivations. At the time I am going to explain how we are going to get each and every formula in detail. But for NEET students and IIT students, this is very useful to save the time. Why? Because such a kind of problems also you can solve in less than 15 seconds. That is very helpful to you to save the time in the examinations, NEET and IIT. So my dear students, remember these tricks. How to remember the formula. In this session I explained to you how to remember the formula to calculate acceleration of the system in different situations. In the case of massless strings, inextensible strings, massless and inextensible strings, and massless and frictionless pulleys. Okay, my dear students, we will continue in next session with a new concept. Thank you, my dear students.